Agricultural communities developed approximately 10,000 years ago when humans began to domesticate plants and animals. Fast forward to the past 50 years, the agriculture industry has radically transformed. Advances in machinery have expanded the scale, speed, and productivity of farm equipment, leading to more efficient cultivation of more land. Seed, irrigation, and fertilizers also have vastly improved, helping farmers increase yields. After decades of evolution, starting from mechanization and the Green Revolution, disruptive technologies have ushered in precision agriculture. Future agriculture will use sophisticated technologies such as robots, temperature and moisture sensors, aerial images, and GPS technology. These advanced devices, robotic systems, and precision agriculture will allow farmers to be more profitable, efficient, safe, and environmental friendly.
Now let's have a quick walk around through the GitHub repository for this entire project. You can find all the details about this project on the introduction readme file. It has details about the dataset, the link to the dataset, the module workflow, how you can use this entire project on your system to make predictions. The final report is mentioned in the report folder. The source folder contains the dataset, the documents of the minutes of meeting for a team, the references of the code and the dataset. The result folder contains the result of the final model. The task folder contains the individual contribution of each of our collaborators. We divided the entire workflow of the model in such a manner so where we'd be able to utilize the expertise of each of our collaborator and mention it separately. So compiling all these Jupyter notebooks, we came up with a final model. As you can see, the first step being we imported the libraries, then we uploaded our dataset. We verified the data by reading the first and the last 5 rows. We checked the size and the shape of the dataset. We went through the columns. We find all the unique values in the label column. Then we saw for the data types of each of these unique feature. Then we counted them and created a heat map to see the correlation between each of these features. Then an important step, separating the features and target labels only to focus on those particular features that are apt for model training. We splitted our training and test data, and then finally we began with training our machine learning models. We trained the decision tree. We checked its precision, recalled the F1 score and the support on test data. Then we calculated the cross-validation score and saved it as a pickle model for future deployment. Similarly, we have trained all the remaining machine learning models, the Gaussian naive Bayes, the support vector machine, the logistic regression, the random forest, the XGBoost, and saved all these models as separate pickle objects that can be further used for deployment. At the end, we have created an accuracy comparison to check which of the model has performed the best on test data, and we'll be using those particular models to make predictions. For making a prediction, we have given inputs as an array and chosen the random forest model in the first cell. As we can see, the coffee has been returned as an output. That means that for these given values, if we choose the random forest model, then coffee will be the best suited crop to cultivate in a particular area with these attributes. And similarly, we have used the naive Bayes model also in the second cell, given it an input array, and then make predictions using that. Now, to conclude our presentation, what I can say is that machine learning is everywhere throughout the growing cycle and the harvesting cycle. Though this is still the beginning of the journey, but machine learning driven farms are already evolving into artificial intelligence systems. At present, machine learning solutions tackle individual problems, but with further integration of automated data analysis, machine learning, and decision making into an interconnected system, farming practices would change into the so-called knowledge-based agriculture and help promote smart and sustainable agriculture. That's it from my side. Thank you so much.